Um, so this is a geometry website. It's called Desmos.com and allows me to deal with geometry. What did I just draw? Can someone just say it? What did I just draw? Yeah, it's a line, huh? That's pretty obvious. Okay, watch this now. Now what? Array. A line goes on infinitely in both directions. Let me do that again. Look at infinitely. Array has a beginning point and goes on forever in any direction. Notice the difference between array and a line. Okay, so here's array. Let me get rid of this line. So I got array. Let me draw another array. I'm going to draw another array that has the same initial point, or shall I say starting point, right here. Okay. So look, I got two rays now that come together in the same initial point. The space in between the two rays is an angle. So this space where my hand's at is the angle. It's the space in between two rays that meet at the same initial point. That's all it is. So on your notes now, check it out. The first word is angle. Go ahead and write this definition. Put in a colon there. Go ahead and write the space between two rays. The space between two rays. The space between two rays. First word. Rocking and rolling. This coffee's good too. All right, so let's see. The space between two rays. Pretty simple. Let me go back to my picture. Go back over here. Now notice the space between the two rays can change. Look at the space is bigger. In between the two rays is bigger or smaller. Now, how the heck am I going to measure that space? Can I measure it with a ruler? Let's see. Here's my ruler. What's the space in between these two rays? Well, let's see. From here to here, that's about, let's see, 3.5 inches. Well, how about from here to here? It's about 13 inches and so on. It gets bigger and it gets wider and wider. So how the heck am I going to measure the space? Is the question. It's not going to be with inches. It's not going to be with feet. Does anybody remember from a prior math class to Mugia? How do you measure the inside of an angle? Do you measure it in feet? Miles? Watch this. What are those called? Look at that. Look at the number. What are those called? The little bubble. They're called degrees. So angles are about rotation. Look at this. 39-degree angle, 57-degree angle, and so on. How about a perfect right angle? That's going to be 90 degrees right there, like an L shape, perfect L shape, right angle. You've seen this before, I'm pretty confident. So the way to measure the inside of an angle, that space is called degrees. Okay? Now, flip your page over. We only defined one word, I know that. Flip the page over, and you have 4 kinds of angles. Miss Horley, what's the first one on the left called? It's called an acute angle. And what is the definition, please?
Measures greater than 0 degrees and less than 90 degrees.
So look at, here's acute angles. Greater than, look at, here's 0 degrees right there. There's 0, and now, so all these are acute angles, but it has to be less than 90. Once it hits 90, what is exactly 90 degree called, Miss Poteo? A right angle. So that's your second one right there in front of you. Right angle. Greater than right angle, Miss Reyes. What's a greater than right angle? Look at, these are obtuses. And last but not least, Miss Carmona. What's this, the 180 called? What's the name of the 180 degree angle? Straight angle. So there's your 4. Simple. You've seen this before, I'm pretty confident. They're right in front of you, the 4 types of angles. Underneath that, you have a bunch of space for notes. Let's rock and roll. Let's draw an angle together. So you have all that space. Okay? Go ahead and draw with me an angle. Just do like this, nice and big. 2 rays. Do that for me. Draw a nice big angle with all that space, please. Really, Phyllis? Can you do this again? Fall the way right now. I have the floor. All right. That initial point that the 2 rays meet at, this point that they share, who remembers what that's called from a prior math class? One more time? Boo! I heard it. I think I heard it. Starts with a V.
Vertex.
You're the man. All right, vertex. Let's label that point, that's the vertex. Let's label with any letter. I'm going to go F for Florida since he said it. That's point F. Doesn't matter what letter. F for Florida. I'll label this point over here A for Ayala since it was Yanni. Point A on that ray. And R for Ruiz. So I got a point on one ray, a point on the other ray, and I got the vertex I named point F. So far, so good. If we want to talk about an angle, just talking about it, we can name it like Merbert or Herbert. We can start naming angles that way. Or we can use the classical way that all mathematicians use. If we want to start talking about an angle, we name it 3 different ways. So underneath this, we're going to write names. Names. The first way to name an angle is simply by the vertex. The vertex is point F, so we can call it, name it angle F. Angle F, but I'm going to use the angle symbol. Check this out. Angle, it's like a little angle. That's all. It just looks like a little angle. Watch the symbol. Angle F. That's one name for it. Write that down. Angle symbol F means angle F. There's another way to name an angle, though. 2 more ways. I can use a 3-letter method, like connecting the dots. I can call this angle AFR. Angle AFR. Notice how the middle letter was the vertex. If you're going to use a 3-letter method, you got to ensure that the middle letter is the vertex. So a legitimate name for this angle is angle F. A legitimate name for this angle is angle AFR. Who can give me the last legitimate name? Using the 3-letter method. RF. Thank you, Ms. Reyes. You're the one who raised your hand. Angle RFA. 3 legitimate names. Notice, again, I'm going to reiterate and stress, if you're going to use a 3-letter method, make sure the middle letter is the vertex, or just think about connecting the dots. RFA. It kind of outlines the angle itself. You connect the dots. Rocking and rolling. We got a vertex. We know how to name an angle. Now let's talk about measuring an angle. Watch this. What if I wanted to measure this angle how many degrees is this angle? Well, I've used a protractor, and tomorrow I'm gonna pass out protractors. They look like this. This obviously is a Jurassic size one for my smartboard. Yours is gonna be about yay big. I'm gonna pass them out. We'll practice that tomorrow. But watch me do it. I'm gonna use this protractor to measure the angle I just drew. Watch. Drag this puppy down. Let me drag it down. How big is this angle in degrees? Let's see. Let me move this up more. Get all the letters out of the way. Okay, so this hole with the cross in the middle is where I'm going to place the vertex. Watch. Rock and rolling. And the initial ray, I'm gonna line up with this line that has 0 degrees. Look at 0 degrees, 10 degrees, 20, 30, and so on. I'm using the inside numbers because this angle opens up this way, so it starts with 0, so I'm gonna use the inside numbers. I'm not gonna use the outside numbers because the outside number starts with 180 degrees and it goes to 170, 160. I'm using the inside. So watch this. Let me line up the vertex in the middle of that hole. You're gonna do this tomorrow. Right now you're just watching me. Okay, there's 0 degrees. Now, let me see where the other ray hits. 10, 20, 30, 40. This is about 43 degree angle. About 43 degrees. And look at the way I'm going to do it. Look at the way I'm going to write it. You don't have to write this down, just watch me. Approximately 43 degrees. Look at a little bubble. It means degrees. I always use approximately sign. So pretty nice. Approximately looks like that. Do this. Because we always use approximate if we're going to measure something, because there's always an element, no matter how small and slight, there's always an element and degree of human error. So this is approximately 43 degrees. What if it opened this way? Watch this. Let me flip this puppy. Let me flip it. Flip. Left to right. Now look at the same angle. It's opening this way now. At this point then, so I just flipped it. I'm going to use the outside numbers. Look at the outside numbers start with 0 over here. So let me line up my vertex in the hole. Watch. Now I'm going to use the outside numbers because the angle is opening this way instead of this way. And look, it's still about 43 degrees. Same angle, it's just opening a different way. So the outside numbers I use if the angle's opening this way. The inside numbers I use the angles opening this way. Either way, it's still the same degrees. We're good? Go ahead and take about 1 minute